President and CEO of United Launch Alliance, Tori Bruno. Jim Chilton, Boeing Senior Vice President of Space and Launch Division. Steve Stitch, Deputy Manager of NASA Commercial Crew Program, and Kirk Shireman, Manager of the International Space Station. We'll start with questions in a moment, but before that, I'm going to open it up for opening remarks from the NASA Administrator. Mr. Administrator?
All right. Well, thank you, Bettina. Thank you for coming to the press conference. I want to start by just making sure everybody knows that today a lot of things went right. And this is, in fact, why we test. Just a few minutes ago, I got off the phone with the Vice President. I gave him a briefing on where we are. He maintains that he is very positive, as the Chairman of the National Space Council, in our ability to once again launch American astronauts on American rockets from American soil. So we did have, obviously, some challenges today. When the spacecraft separated from the launch vehicle, we did not get the orbital insertion burn that we were hoping for. It appears as though the mission elapsed timing system had an error in it, and that anomaly resulted in the vehicle believing that the time was different than it actually was. And because that timing was a little bit off, what ended up happening is the spacecraft tried to maintain a very precise control that it normally wouldn't have tried to maintain, and it burned a lot of prop in that part of the flight. And when that prop got burnt, it looked like we weren't going to be able to go ahead and rendezvous with the International Space Station. By the time we were able to get signals up to actually command it to do the orbital insertion burn, it was a bit too late. And the reason it was too late is because it appears, and remember, all of this is very early and preliminary, and we're learning things moment by moment, but it appears as though we were between TDRS communication satellites, which meant we couldn't get the command signal to tell the spacecraft that it needed to do the orbital insertion burn soon enough. A couple of things that are important to note, and I want to be very clear about this. We as an agency and our partners at Boeing and ULA have committed that when there is something that is a challenge, we will be very clear and transparent about it, and we will share information as early as possible. And we have done that, and we will continue doing that. It is important for us to build trust with the American taxpayer so that we can continue to do these magnificent things. But know this, a lot of things today did, in fact, go right. I would also attest that it could very well be that had we had Nicole Mann in the spacecraft, remember what the challenge here, this anomaly has to do with automation. And Nicole and Mike are trained specifically to deal with the situation that happened today where the automation was not working according to plan. And if we would have had crew in there, number one, they would have been safe. To be very clear, our crew would have been safe. And in fact, had they been in there, we very well may be orbiting, or we may be docking with the International Space Station tomorrow, had they been in the spacecraft. So a lot of things went right today. I want to be really clear. A lot of things went right, and this is why we test. And because we are now in orbit, and in fact elevating our orbit, we're going to get a lot more data and a lot more information in the coming days. So this is all very positive in general. I would also say that we had the Centaur upper stage with 2 RL-10 engines demonstrated a very successful flight that something it had not done since 2004, which is a Centaur with 2 RL-10 engines. So a lot of I wouldn't necessarily say that was a first, but a lot of firsts did happen today that were very good, and we're going to continue to learn from what's from this test flight. So Tori, I'll turn it over to you. You can talk about some of the things that are important to ULA, and then we'll turn it over to Jim Chilton to talk about what's important to Boeing, and then we'll open it up for questions.
Thanks, Jim. So as you know, this was the 81st flight of an Atlas V launch vehicle, but it was a uniquely configured Atlas V for the crew mission, and so it is very significant that it was a nominal flight. As the administrator has said, there were a number of test objectives simply associated with that. We successfully flew the capsule without a payload fairing. The aerodynamic skirt that was added for control of aerodynamic loads functioned beautifully. The ascent covers on the capsule separated nominally during flight. The aeroskirt separated nominally. We flew the flattened low-G reentry trajectory uniquely for crew safety purposes perfectly. And at the point of separation of the spacecraft, we achieved those separation parameters and, in fact, literally hit a bullseye with several parameters in the vanishing decimal points of accuracy. So all of those activities worked just perfectly and satisfied those test objectives. Additionally, we did have a forward-facing camera on the front of the Centaur that was able to observe the spacecraft separation, which was significant in terms of confirming Boeing's observations that my colleague Jim Chilton will talk about. And I'll hand it over to you, Jim.
Okay. Well, I'll echo the great human-rated Atlas performance. This is not your father's Atlas. Not only has it got a dual-engine Centaur, but it's got a lot of human-rated upgrades. So that was a big success. Let me jump right to what the timeline was. As soon as the spacecraft separates from the launch vehicle, it's programmed to do an orbital insertion burn, which is how you go catch the space station and rendezvous. That burn didn't happen. It appears that the vehicle was using a mission elapsed timer. That was not the mission elapsed timer the mission was on. We don't understand the root cause of that. We don't know if that was inherent somewhere in the vehicle or was caused by some event. Just haven't got, what we know is the vehicle was not on the right timer. We don't know why it thought that it wasn't. The thing to know is, of course, once the vehicle thought it was at a different time in the mission, being autonomous, a lot of this runs on a timer, it began to do burns and attitude control. The flight control team reacted in a very professional manner. They recognized and the engineers diagnosed this quickly. We began to send commands to take it over. As Administrator Bridenstine mentioned, there was some delay in that until we could get a positive link as we went through satellites. Again, that's our hypothesis. That's why the link wasn't received, but we've got data to review there. And so the flight control team put the spacecraft in safe orbit. We're tailed to the sun, making sure we maximize charging. All systems are good, cooling, power. In addition to the flight dynamics, we're also able to do far-field sensor looks and space-to-space checkouts of our optical system, so all of that is underway. The orbit we're in today, the reason we picked it and put it there is that allows us to return to White Sands in 48 hours. So without knowing exactly what was going on, the team quite rightly said, let me put the spacecraft in an orbit that I know I can control and get home and give the engineering team time to thoroughly figure out what's going on. So spacecraft looks healthy. We're in an orbit we like. It is.
By the way, that was the absolute right decision for this mission, to make a decision that we needed to come home and make sure we can land at White Sands. That is an important test objective in itself.
Yeah. Safety first. You want to make sure you go up, you go to space, and you come home where you intended to go. So I commend the flight control team and the combined Boeing-NASA team that called that very early. Where we sit now in the orbit, we're doing a propellant inventory management. It appears we have about 75% of the flight test propellant available, and the team will go figure out what subset of our overall test objectives can be achieved with the propellant remaining while preserving a safe return to White Sands. And with that, I guess I'll turn it over to Steve.
Thanks, Jim. From the Commercial Crew Program perspective, I want to just congratulate the team for the work that they did today, both the Boeing Flight Control team, the Boeing Engineering team, and the NASA team that supported them. Having been in operations in the past, I thought the team did a phenomenal job with a very tough scenario coming off the vehicle with the time that didn't look right. And the team didn't have a lot of data to make decisions, but the team did a phenomenal job of getting the Starliner spacecraft in a safe orbit. The plan for the rest of the day, before we came over here, they're going to do a couple of raising burns to adjust the orbit up. That'll happen this afternoon around 1:40 or so Eastern, and the second one would be around 2:25 Eastern. They're about 20 meters per second each to raise the orbit up to optimize the landing at White Sands, which the earliest landing would be on Sunday at White Sands. I think the time will be around 7:30 a.m., but it'll change with time. From a program perspective, we learned a lot today with the launch vehicle and the spacecraft. This vehicle is set up to fly today the exact trajectory we'll fly with a crew on board. We had the emergency detection system on the Atlas, and that's a system that would, if anything would happen with the rocket during powered flight or on the pad, could command a separation. That system was flown in an inactive mode today, and we're going to collect data on that. And the team is replanning the mission to collect as many objectives as they can on the spacecraft. I would say before I came over, the spacecraft is doing great. You know, the thermal control system's working fine. The flight computers are working well. The cabin environment's great. The spacecraft has recovered well and is doing well. So we'll work this over the next few days. You know, when we look ahead, we'll work with the Boeing team and make sure we're safe for entry. The thing we have to do now is we understand we had a problem with this timing, with this very important insertion maneuver. We'll have to go look forward and look at the deorbit burn and entry just to make sure there's no hidden problems there. And so we'll go look at the software. We'll probably do some runs in a simulator in the ASIL and to make sure that's all safe. So overall, you know, a good day for us. We'll learn a lot from this mission. We still have a lot of objectives ahead of us. And then the deorbit and the entry for this vehicle, when you look ahead to a crewed flight, is hugely important to get that with this particular capsule, this particular shape, separating the service module. So we have a lot of things to look forward to on this mission. I'll turn it over to Kirk.
Yeah, good morning. It's a pleasure to be here. Of course, as International Space Station's role in this mission is really largely twofold. One was to to execute the pieces of the demonstration flight when the Starliner is in the vicinity of the International Space Station. Second piece is actually to train the crew to be ready. And of course, we did accomplish that first part. I had the chance to speak to the on-orbit crew yesterday, and they were ready and excited to support the docking. And so that part is true. As we go forward here after today and learn more about what the capabilities of the vehicle that are remaining and what objectives can be accomplished, it's quite possible some of those objectives in coordination with the ISS are possible. We'll see how that goes. The last thing I wanted to mention about learning, which is really, really important, is that we had an off-nominal situation on orbit. We've been working for years with our international partners to be ready for U.S. astronauts to fly on U.S. rockets off of U.S. soil. And so we've actually coordinated with them. So I spoke with my counterparts this morning. They're aware, and we're working with them as we go through this too. So there's the technical learning that's going on, and I would say the programmatic learning is going on as well. And people around the globe are supportive of what we're doing and looking forward to learning everything we can from this flight and be ready to fly our crews here in the very near future. Thank you.
And speaking of crews, we astronauts, including Chris Ferguson, Nicole Mann, and myself on the next crew, we were watching from we divided and conquered. We had some of us that were at the Atlas Space Operations Center, the ASOC. We had some of us that were at the Boeing Mission Control Center, and we saw a great launch. We watched the OI burn as it played out, and we kind of imagined ourselves as if we were on board. In fact, I even had my flight checklist that we've been developing right in front of me to watch what was going on. And Starliner has a robust manual capability, and Chris Ferguson, Nicole Mann, and myself, we'd like to think that, as the administrator was saying, that had we been on board, we could have given the flight control team more options on what to do in the situation.
We train extensively for this type of contingency. And had we been on board, there could have been actions that we could have taken. And we will continue to develop those actions. And that robust manual capability is something that's required. This vehicle is a new level of automation that we've never seen before. And so what we're really doing is we're testing that automation, and that's why you have test pilots on board, especially for these early missions. That's our job. That's what we're trained to do. We are looking forward to flying on Starliner. We don't have any safety concerns. Everything on the ascent, all the systems that would keep us safe have functioned properly on the launch and currently on the vehicle. We're looking forward to all the test data, and we're looking forward to a landing at White Sands.
Well, thank you. With that, we're going to take questions. Please identify your name and the name of your organization. We're going to do one question per reporter because there's a lot of interest. And then if we have time, we'll go back to you. So with that, do you want to call them?
I'll let you pick, Bettina.
Right here.
Much may have gone well today, but it clearly went was imperfect. So does what happened today necessitate another orbital flight test? When would you work that into a launch schedule? And doesn't that push back the ultimate goal, which is to get folks like these two onto a rocket and into space?
So I think it's too early to know. I think, as Jim Chilton alluded to, we don't know what the root cause is. We know that the mission elapsed time was not correct, that it was going off the wrong time, but we don't know what the root cause is. I think it's too early for us to make that assessment. But certainly, when we do make that assessment, we will communicate that as soon as we do.
But you can see a scenario where, despite what happened today, it wouldn't interrupt the ultimate goal, which is to get these guys up on the next one?
Yeah, I'm not saying yes, and I'm not saying no. I think it's too early. It's too early to make that assessment.
Yeah, I think from my perspective, commercial crew, we would have to look at what the problem is and see what the ramifications are to the different parts of the software. You know, if you think about the parts of the mission that's ahead for us, we still will get to do a deorbit and entry and check out those critical pieces of the mission. If you think about the critical parts of the mission from a crew, it's launch and landing. So we'll collect that data and we'll understand the root cause of this problem, and then we'll have to go see what's the next step relative to the next mission.
Mm-hmm. And please wait till the microphone gets to you before you say your question.
David Curley from ABC News for the astronauts. What does this say about automation? And do you find it striking that in 2019, with a sophisticated vehicle as this is, that the wrong clock was used?
So this is why we flight test, right? We're trying to get all of the bugs, if you will, out of the system. I'd like to compliment Boeing. They've done an exceptional job with their different system integration labs for the avionics. They've in Houston and Florida to try to wring out everything. And there's always something. Rosanna Dana said it best. There's always something, right? And so that's why we flight test. And our job is to wring out all those issues so that when we send operational crews, folks that may not be astronauts that may not be test pilots, those are just focused on getting to our beautiful International Space Station and back, that they can just that they can trust the automation. And so the first time it happens, and that's why we have the manual capability that we have. It's not just a good idea. Boeing, embraced the idea, but it's a NASA regulation that if we're going to have humans on board, have all the automation you want, but always have a way out.
In some ways, this was the toughest time for automation, I would say. If you think about what was happening, right? The automation of the launch vehicle gets you into orbit, but then it was handing over to now the automation of the spacecraft. And so that critical time frame, clearly we missed something with this time that we didn't see it in any of our simulations that we did, any of the runs in the hardware in the loop runs where we have a very high fidelity Boeing spacecraft that you run them through. So something we clearly missed, but it's in this time frame where the automation hands over, if you will, from the launch vehicle to the spacecraft, that clearly the time got messed up. So we'll have to go figure out what happened and then go solve the problem.
And I'll just add, clearly the spacecraft was not on the timer we expected her to be on, and that was a surprise. We don't know why. We don't know if it started that way. We don't know if some event caused it to be that way. Our most important job right now that we have the spacecraft where we like it and it's operating fine is to diagnose that and then compare that same cause or anything similar to all the reentry functionality so we can complete this flight test safely and successfully.
Marcia Dunn, Associated Press for Mr. Chilton. Everything was going so great for 15 minutes, and well, actually for the first half hour. I'm sorry. In any event, how much of a blow was it to have everything go so well during ASCENT, and then for this to happen? It must have been pretty devastating for the team.
So. Yeah, let me talk about the team. I think that the team comes in a couple subsets, the flight control team and the mission management support team, all those technical people who had trained for this to watch off nominals. There was no emotion. There was just professional execution and setting the right priorities about where to put the spacecraft. I did have a chance to go by. We build the spacecraft right here at the Kennedy Space Center, and of course I went by before coming here to address the team. And yeah, these are passionate people who are committing a big chunk of their lives to put Americans back in space from our soil. So it's disappointing for us. But that doesn't mean we're not going to diagnose it, figure out what the right thing to do to go forward, whether it's what kind of next flight test we fly, and keep going.
And I'll add that I went over to the ASOC, obviously, and observed Jim's team who was working at there. Consummate professionals, that's how this industry works. As he said, we put our heart and soul into these missions, but when we're executing them, when there's a challenge, when there's an anomaly, people move to that, and they work the problem, they work the anomaly, they do the right thing, and then we think about the rest of it later.
Hi, Chelsea Go at space.com. So I'm curious currently, what are the odds of successfully recovering and refurbishing the spacecraft once it lands in White Sands? And then if you could just speak a bit more to, breaking down the timeline of, from what we now know, next steps, both with the spacecraft and the mission overall. Thank you.
So, Jim, I'll leave it to you.
Certainly the first one, the odds are high, really the same as if we were on our way to rendezvous is how it looks today. We're just going to come home to White Sands, which was always the plan. The spacecraft is designed to be reusable. There's nothing about this event with the mission elapsed timer. We ended up in a place in space we didn't expect to be, but we don't see hardware issues that would drive a different refurbishment and turnaround. And I'm sorry, the second part of the question?
If you could just speak a bit more to the overall timeline for the mission and for moving forward with Starliner.
Okay, well, for this mission, we have protected a return to White Sands in 48 hours. So that at the risk of getting out ahead of my NASA colleagues, I'll call that baseline, because we're certainly going to go diagnose what's going on. If we need another day to diagnose what's going on, we'll do that. If we diagnose it and the joint team, the NASA Boeing team, says, hey, we could stay a little longer and get a larger proportion of the test objectives completed, we'll look at that. We'll definitely open to that.
Yeah, and today, as I said, the major objective is to really do a couple of orbit raising burns to raise the orbit to set up the landing at White Sands for 48 hours later. So the team's off working that. They're also off working at what kind of mission objectives can they add to the mission? Can they do we have a couple of demonstrations of capabilities that we do before we go rendezvous with the space station. They're off looking at can they do some of those demonstrations to check out those systems. And then along the way, is there anything else they can do to check out the spacecraft, not only ahead of the landing, but also for future flights? So they're off thinking about those sorts of things.
And we know even with the 48-hour, if we even coming home Sunday, we know that we can do far-field type observations for our docking system. We know we can do space-to-space type observations. We can check where we are relative to other spacecraft. So we're already getting some value there.
Irene?
Thanks very much. Irene Klotz with Aviation Week in Space Technology for Steve Stitch. I realize this might change, but currently, is it a requirement of the commercial crew program that there be a docking of these spacecraft prior to astronauts flying to the space station?
Yeah, we don't have any requirement to do that. What we both Boeing and SpaceX proposed a mission to do an uncrewed test flight that demonstrated a docking. So I would not say that's a requirement. It's something that is nice to have, but I wouldn't say it's a requirement for a crewed flight.
What is the current orbit of Starliner, and are you this resetting of the mission elapsed time that's now resolved to the point where the orbits will happen and this deorbit burn to get to White Sands also would happen?
Yeah, I mean, the orbit is 216 kilometers by 186 kilometers. That's the apogee, the highest point, to the perigee, the lowest point. The timer is not an issue anymore. I mean, it's reset, and we're able to do everything that we need on the right mission elapsed time. So that shouldn't be a factor for the rest of the mission.
Yeah. Chris?
Thanks. Chris Davenport from the Washington Post for Mr. Chilton. You talked so much in leading up to this flight for years about the redundancy built into the spacecraft with the computers. Since the clock seems to be so key to the thrusters and the maneuvers and the insertion burn, was there no backup to the clock?
We don't understand why the spacecraft got off the expected mission elapsed time through all the redundancy trails and everything else. So I'm not able to answer until we diagnose. But we'll let you know when we know. You'll know.
I think it's safe to say, correct me if I'm wrong, but it's safe to say that we could have commanded the orbital insertion burn directly in time to actually save the mission and enable it to go to the International Space Station. It just so happened that at the time when we were trying to do that, we were between TDRS satellites. As far as we can tell right now, there's a lot of data that we need to go review. But Chris, I'm just sharing this because I want to be as open and transparent as early as possible. So there is a backup. The backup is to send it a command, right. And that command just did not get received by the spacecraft because of where it happened to be at the time and where our TDRS satellites were.
Faust.
Jeff Faust of Space News. Can you say what fraction of the mission objectives you will not be able to achieve because you will not be arriving at the space station?
I can't. Job one is it's been 3.5 hours. Job one was get her to the orbit we want and start planning your forward ops. We know we've already gotten some, but Jeff, we'll have to just get back to you. We haven't tallied yet.
Yeah, I was going to say the same thing, Jim. It's really been too early. We've been really trying to work the problem, get the spacecraft in a safe orbit, figure out the final options for the rest of the mission. So we haven't had a chance yet to reconcile what we think we can achieve on this flight and what we had planned to achieve.
Okay. We have some reporters on the line. We're going to go to Michael Sheets from CNBC.
Hi, all. In terms of the objectives remaining, what are you looking at that looks achievable, and where do you go from here in terms of salvaging what you can from the mission?
Well, I think there's plenty to achieve. Rather than drag you through narrow objectives, I already mentioned that we have part of our docking system and our control of the spacecraft in space has think of them as eyes. It's a system with 4 different types of sensors. Some are for long range, some are for short range. We're obviously going to be able to test all the long range. We have the opportunity to run some subsystem tests. There was some planning to take subsystems without crew to places that we wanted to be able to show autonomously. And then finally, I would say, and this is something we're studying and haven't committed to, and Kirk's eyebrows may be instructive here, but as you approach the space station, you go into a corridor and there's a keep-out sphere, and there's probably an opportunity to practice spacecraft guidance and control, just not at the same proximity to the station that we previously thought.
And obviously the deorbit and entry objectives, there's lots of other things that the spacecraft is doing that we're learning about how a spacecraft performs in orbit, how the radiators are rejecting heat, solar rate pointing and charging the batteries. There's many, many things that just flying in orbit about the Earth that we're learning about the spacecraft and how it performs, which will be huge for the crewed flight test.
We're going to take another question from the line, then we'll go back to the room. Lauren Grush from The Verge.
Hi, thanks for taking my question. So I'm curious, then, how long exactly do you have for a window to do the insertion burn, and what exactly could the crew do if they were on Starliner to make that happen in case this ever happened again?
Well, I think the first one I can take. When we realized the orbital insertion burn didn't happen, the protocol is to just go send the spacecraft instructions to burn another one, and I'm working from memory, but I think it was 7 or 8 minutes after we knew the first one didn't happen. And of course, we didn't have positive link with a TDRS, and we couldn't get that signal through. And by the time we did get positive link from TDRS, we chose to go to a different orbit instead of send the burn. If Nicole and Mike don't mind, I'll hand over what you would do to them.
Sure. So we have the capability on board to stop the automation and take over manually to fly. There's different levels that we can degrade down to, all the way down to the point where we are manually controlling the firing of thrusters. And so in this case, we could have stopped the RCS thrusters from firing and then entered the burn ourselves and either had the automation or the computer systems execute that burn, or we could have flown that burn manually. As far as coming back home in an orbit that the spacecraft is in now, it's certainly safe. We have the capability to live on board for an extended period of time. And then we would come back nominally. In this case, if for some reason there was still an issue with the automation, we do have that capability to do the deorbit burn and fly and land manually.
Yeah, these are the things that we spend our time training for in simulations. We spend some time on how it go when things go right, but we're always looking at what if things go wrong, just so that we can provide that mission assurance and safety for everybody.
Mm-hmm.
Hi, good morning. Tom Costello with NBC News. I had two quick questions to drill down on what whether you could do a crewed mission. Not having this experience isn't a critical component of the crewed mission, or rather of this unmanned mission. Wasn't it to test your docking capabilities? And can you put a crewed mission together and approach the station without having at least done it once in this automated mode? That's my first question. And my second was, on the satellite link communication failure, I guess I was surprised that you would not have had constant comms with the vehicle the entire time, that foreseeing some sort of a glitch or a failure to communicate between satellites, that would not have already been ironed out in advance.
As far as that, the reason the commands weren't going through, we still need to look at that. It very well may be that there's another issue there. We're just assessing what we think the possibility could be early on, but there's a lot of data that we're going to have to go back and look at to see if there was an issue there that we can fix. What was your remind your first? Oh, docking.
Can you approach the station
yeah.
to dock if you've never done it
You bet you can.
in this kind of a test mode?
Yeah, remember, the space shuttles never flew autonomously. They never did. So the answer is yes, you can do it. We built the space station with the space shuttles, and every single one of those missions was crewed every time.
Yeah, I mean, I think in some cases having a crew on board gives you some better or different enhanced capability for responding to some failures for a docking. So I agree with Mr. Bridenstine. There's absolutely, you could do a mission without having automated docking with the crew.
If you haven't decided whether you're going to allow it.
Yeah, well, that's something we got to look at. We got to look at all the data, come up with. Look, remember what we do as an agency. We do really difficult things, and we do it all the time. And yes, we have challenges, but what do? We figure out what those challenges are, we fix them, and we move forward. That's what we do as an agency. It's our history, and it's what we're going to do now. And that's not a problem. We're going to keep doing it.
Joey?
Thanks. Joey Roulette from Reuters. This is for Jim and Jim Chilton. What could you learn from a Starliner staying longer, more than 48 hours in orbit? And a second question, maybe not talking about this particular mission, but this kind of might be repetitive, but would you support a decision to launch crew on Starliner knowing that the spacecraft has not docked yet to the ISS?
Certainly, I'm not ruling it out. Personally, I'm not ruling it out. I'm not saying we're going to do it, but I'm not ruling it out either. Again, remember, when we had space shuttles, every single one of those missions was crewed from day one. The very first time we launched a space shuttle, it had people on board. And the first time that it rendezvoused with an object in space, it had people on board. These are not things that are new to NASA, but I want to make sure that we understand what the challenges were that we just had, and that we get those fixed and make sure that there's not some larger systematic problem. Maybe it's if this is a software challenge, then is that systemic, or is it just, this happens to affect this one particular aspect of the flight? So we need to look through those things and make sure that we're doing the right things for the right reasons. What was you had another question there?
What could you learn if from the Starliner if it stayed longer than 48 hours in orbit before coming back to White Sands?
Yeah, well, I think it very well, we could make a decision in the coming hours to stay longer than 48 hours. I'm not going to suggest we are. I think we have made the right safe decision, which is we're going to protect landing at White Sands. That's what we want to do. We don't want to miss the opportunity to land at White Sands because that in itself is going to be a test objective. But certainly if we stay longer, as was mentioned earlier, there's station keeping that we can do with the International Space Station, possibly. I'm not suggesting we can. We need to make sure that we can do that if it's within the realm of what's possible. But yeah, there's other test objectives. Jim, if you have anything to add.
Well, I'll throw out that part of the plan as we approach station was to demonstrate margin in our maneuver capability. We have a spacecraft in space. The cabin is fine. The cooling, all those systems are working. What we wanted to show as we approached an autonomous docking was we had margin in the control system when she doesn't veer off course too much. And we could go do all of that. What we were going to do is stress it a little bit. So by the time we got close to the station, we were in the fairway more, to use a golf analogy. So extending the mission could do more of that.
And I think the extension will be driven by the White Sands. We don't end up having a White Sands landing opportunity every day, and so we'll have to look at when that landing opportunity is, what the weather is for that opportunity, and then factor in our understanding of the problem we had relative to insertion with does that in any way affect the deorbit and entry guidance modes of the vehicle. And so I think those are the factors: how many mission objectives we can get, what's the weather looking like at White Sands. If I don't land on Sunday at White Sands, when's the next opportunity? And we'll just have to make the flight control team, Richard Jones, the ascent entry flight director, and the flight control team with the mission management team are doing all the right things, looking at all the right trades. Obviously, it's very early in this whole mission, but they'll factor all those things into when we come home.
Mike Magnoli from Fox 35 News. It's a follow-up to Tom Costello's question. This issue about the capsule being between two satellites. I wonder if that segues to another issue about how crowded space is becoming, and with all of these satellites going up all the time from Space Coast moving forward, do these missions need to be changed, taking that into account, because it's getting really crowded up there?
So there is no doubt it is getting really crowded as a nation. The President has issued Space Policy Directive 3, which gives the Commerce Department the charge to do space situational awareness and space traffic management. Currently, it's done by the United States Department of Defense through what's called the JSPOC, the Joint Space Operations Center. Their data does come to NASA through the Johnson Space Center. And, of course, we have some really whiz-bang, I would say, people that do really amazing kind of science with it, and they come up with very accurate assessments as to is the International Space Station at risk? Are our crewed capsules at risk? These are things that we do take very, very seriously. I will also say that regarding the TDRS perspective, this is a constellation that's in geostationary orbit, well beyond low Earth orbit. So it will not have any kind of challenge with objects in space. Regarding the constellations that are launching from right here at the Space Coast, a lot of those constellations are low Earth orbit constellations, some of them with many thousands of satellites. And the reason they're doing that is because they want to have high throughput, low latency communications so that you can have cell phone-like communications through satellites. And you can't do that from geostationary orbit just because the distance is too far and it doesn't match the protocols for LTE or whatever the signals happen to be at the time. So I would argue that that the orbital debris situation is something that our country, our nation, under the President's direction, is taking very seriously, and we have to keep doing that.
If I could, yeah. I'll add that what we have is a correlation in space where we were between TDRS, but that isn't causation. So our hypothesis is we found ourselves in a place where it was hard to get that link in, but like the timer, we have to go make sure we understand that.
There's up here in the front.
Chris Gephardt with NASA Spaceflight. First off, to Tori and Jim, thank you for the communication today. That was very much appreciated. I just want to make sure I understand this because I haven't actually heard anyone say it definitively. Docking and rendezvous at the station is completely off the table for this. Yes, and I have a follow-up.
Yeah, so we were debating that just maybe an hour ago, and I would say that that's safe to take off the table at this point. I think it's safe to take off the table at this point. It's not worth doing given the amount of fuel that we burned. Remember when the timing was off, the spacecraft didn't know exactly where it was in the sequence. And when that happened, it believed, it seems, and again, this is all very, very early, but it seems like it believed that it was doing an orbital insertion burn when it wasn't. And when that happens, the reaction control system starts working because it has to have very precise kind of station keeping, if you will, very precise attitude keeping. And that very precise attitude keeping burns fuel. And so by the time we got that figured out, we had burned sufficient fuel that if we would have done an orbit insertion burn to get to the International Space Station, it might not have been enough. And so I think the right decision was made by the people who were in the room at the time. The right decision was made to protect White Sands, to make sure that we can get this spacecraft safely back to White Sands, which is an important test objective in itself. So I want to be really clear. The NASA team and the Boeing team need to be commended for making the decision that is in the best interest of our country, for the decision that is in the best interest of the safety of people on the ground and, of course, our astronauts. I will also say that at no time, even under the automated sequence, at no time had we had astronauts on board that were not manually flying it, there was no time at which they would have been unsafe during any of this. And had they been on board, we very well would be on our way, very well could be. I'm not saying we would have been, very well could be on our way to the International Space Station right now. So.
And for other Jim, I know you said earlier that you have a really high degree of confidence of that landing will go fine, but with the timer issue completely unexpected, how are you confident that this won't happen again when the entry sequence triggers?
Well, I think your question is excellent. I mentioned confidence in reentry, but it is a fact. We have to go diagnose the root cause of our timer challenge. And by the way, anything else we've seen in spacecraft behavior as she went into an off-nominal scenario. And we have to not just say that doesn't apply to reentry. We have to say, is there anything in our previous thinking or that's similar that we could be susceptible to on landing? And we've got to go do that before we land. Simple as that.
Okay. We're going to take one more question, and then we're going to wrap it up.
Marcia Dunn, AP again, perhaps for Jim Bridenstine or Steve. Does any of this spill into SpaceX's effort to launch Crew next year? Is there any impact to them that you have to sort through first, or is this totally separate?
Well, there's a lot of things here that your question addresses. Number one, it is important for us as a nation to maintain dissimilar redundancy. So when you look at the Boeing solution and the SpaceX solution, they are not the same. Which means that when we do have a challenge that might set us back, the other one can keep going forward without putting us in a position where we might not have crew on the International Space Station or whatever commercial space stations come after the International Space Station. So both providers are critically important to the future architecture of commercial spaceflight. I want to be clear about that. Both providers are critically important to the future architecture of commercial spaceflight, and there very well could be other providers that get on-ramped in the future. I'm not saying we're going to do that, but there are a lot of other companies that are interested in human spaceflight as well, and a lot of them are making their own investments for their own reasons, even if NASA is not a customer. So I think that is an important point to make. I would also say that one of the reasons NASA manages the commercial crew program is because when we see a commercial provider have a challenge, something that is off-nominal, for example, we can make an assessment if that is a problem for another provider. And the goal here is to make sure that human spaceflight is safe for everybody. So in this way, NASA has a very key role to play here. We've seen this with launch abort challenges that obviously people in this room have been made aware of. And we've seen this with parachute challenges that people in this room have been made aware of. So look, the goal here is for NASA to be able to apply knowledge that we learn from each of our providers to make everybody more safe. And so, yes, we do want to look across the different partners and make sure that we don't that they're not, creating the same mistakes. This is a challenge when we talk about commercial space flight, with NASA being the certifier of these spacecraft. This is a challenge in some cases because intellectual property matters to the companies. And so we have to be careful. We don't want to share intellectual property from one company to another company, if doing so puts one at a disadvantage. But when there are safety of flight issues where humans need to be protected, we absolutely intend to share information. And that is a challenge that we need to continue to work through as we move forward in this commercial spaceflight era.
And I would say, echo just what Jim said. I mean, right now it doesn't look like there's crossover to Dragon, but when we go look at the root cause and we find out what the fundamental issue was, and that may take a little while to figure that out, if we think it applies to either the Falcon or the Dragon, we'll go off and work that with SpaceX. But right now, today, early on, it doesn't appear to be. We've flown one uncrewed mission, Demo 1, in March with the Dragon and the Falcon, and obviously we didn't see this type of anomaly, but once we do the root cause analysis and figure out what happens, we look across both those providers all the time. That's part of our job in the program, to ensure that we fly safely. So,
and I'll add that it's a long tradition in our industry that human safety transcends proprietary information and issues like that, intellectual property. We are not going ever to withhold something that would put other people at risk. That's just not how it's done.
Well, with that, Mr. Bridenstine, do you have any final remarks?
I just want to reiterate. Today, we had a lot of successes, and I would say one of the biggest successes is watching the NASA team and the Boeing team and the ULA team work together in an off-nominal situation to make good decisions that would have been right for our astronauts and right for the country. I think that's a big takeaway. I would also say that we will continue to be, as we learn information. This is not the end. We will continue to get information. We will continue sharing information. And I know we are all on this stage committed to doing that because it's in the interest of the nation, and we want to have support from the public. And to the extent that we can share data, we will do it as soon as it becomes available, and you have our commitment on that. So thank you all for being here, and thank you for continuing to follow this program. It's important to the nation. Thank you, guys.
Thank you all for being here. You can get more updates at nasa.gov. We'll be providing information throughout the day. Thank you again, and check us out at nasa.gov. Thank you.